Okay, good morning, Akshat Kapoor. I welcome you for the introductory class in chemistry. My introduction, students, is very clear. My name is Sunilsikri. I am a science coach, students, formerly adjunct lecturer, New York University, USA. My number can be contacted 058053 WhatsApp and YouTube channel chemistry decoded dash sunilsikri. So students can join, subscribe this channel and get large number of video lectures of chemistry, science and many other events. Okay, students, when I want to introduce to you chemical bonding, you know that in chapter 1 and chapter 2 of chemistry, you have studied the matter is made up of very, very tiny particles, which you call as atoms. The story is that today in the periodic table, you will find about 118 elements have been listed. And you are aware of elements like hydrogen, helium, you will say lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. And in the periodic table, students, what you see? There are certain groups and periods in which the elements have been arranged in the periodic table. And probably you are familiar with some shape of this. We are not going into details of that. See the introductory lecture. Something like this you see, students. In the periodic table, what do you find, students? There are four blocks: S block, P block, D block, and F block. These are your group 1 and group 2 elements: alkali, alkaline, earth metals, transition elements, transition element mostly here D block, and P block elements. You have group 13 to group 18. 13 to group 18, group 1, 2, and here 3 to 12. And here you are called inner transition elements, which are lanthanides and actinoids, F block elements. So the question has always been fascinating that atoms combine, students. Atoms combine. You are well aware of that. You know, oxygen atom doesn't exist. What exists is oxygen plus oxygen is forming O2. In the air, students, you have oxygen gas, you have nitrogen gas. So you have hydrogen and water combining to form H2O. You have carbon dioxide, you have NH3, students. What I'm trying to say that elements or atoms have tendency to form compounds. They are forming molecules or compounds. The question has been what we are saying, the atoms combine and they are forming, student, molecules. Molecules means there is more than one atom, students, which have combined, as I told you, like oxygen gas, nitrogen gas, Cl2, water. H2O is a molecule of compound water. So they are forming molecules, compounds, and the main question was, students, why do atoms combine? Why why do the atoms combine? That is the question. Why do atoms combine? That was a question. in the chapter of the chemical bonding mainly. Why will the atoms combine if they are stable? See, what will the reason? What is the reason? Anything will combine. And we know in science, students, what you know in science. Everything which is not stable will react.
Yeah.
Something is stable, then it doesn't want to react. Now, question is what is stable and what is not stable? In terms of energy, in physics, in chemistry, in science, what you learn, students, what you learn, everything wants to go to lower energy state, minimum energy. Atoms want to be stable means they want to have minimum energy. Atoms will combine in order to lower their energy. And the matter was studied by number of scientists, and what they observed, what we observed, students, you know that certain noble gas elements, noble gas elements, students, you know the names of these: helium, neon, argon, krypton, xenon, radon. These are the inert gas elements, noble gas elements of group 18. They are stable and they do not react under ordinary conditions. They are not reacting. They are not interested to react. They are stable. Why? The question was studied, and you know that what they say, that they have stable octet. This was the first idea which was given. Lewis, that those atoms which have completely filled outermost shell or which have got octet, they are stable. They are stable. They are stable. For example, you are saying neon atomic number is 10. Then you have learned this. You have learned the electronic configuration, students, how to write it. You know what we write: 1s2, 2s2, 2p6. Is it clear? Tell me.
Yeah.
I hope, Akshat, you have learned the electronic configuration, how to write it in the
Uh,
chapter of atomic structure. Did they teach you?
um, like how to write like the protons and neutrons.
No, I'm not. Here you see that we are writing, this is called the electronic configuration. Electronic configuration, students, which means the filling of the electrons in the shells which are present inside the atoms. What we are doing, these are the orbitals, these are the sublevels, and there are rules for writing the electronic configuration. These are the electrons in the first 1s subshell, 1s orbital, you have two electrons. In the second, this is my first shell K, this is my L. L has got two subshells, 2s and 2p, students. In maximum electrons that we can put in S is 2, maximum electrons I can put in P is 6, students. So these are the electrons which are present in this. This is 8, means that the total of 8 electrons are there in the outermost shell. So this is considered a stable outermost electronic configuration. This is a stable outermost configuration, students, and we call this is an octet. So if an octet is achieved, student, we say that okay, it is a stable outermost valence electron configuration. Therefore, the atoms are combining in order to attain stable configuration. What we are saying, in what do you have in the atom, students? You have, what do you say, that this is your nucleus in the atom, and there are electrons which are present, you are saying, in the shells outside the nucleus. There are how many? K, L, M. So the atom, you are being taught, student, you know about it. This is the nucleus which has neutrons and protons. Nucleus contains neutrons and protons, and electrons are present outside. This is the first shell is KLM student like this. K shell can have two electrons. So if I have one electron, two electron, and L can have how many? Eight electron maximum like this. What we have shown arrangement of electrons students. And in the shells, these are the shell student. In the shells, you have subshells. What I'm trying to say, if you have K shell, or this is also called orbit, first orbit. This is the first orbit. My K shell or orbit. The first one, this is when we say n equal to 1, n equal to 1, first shell. And 2n square rule, this is the maximum electrons. Maximum electrons that can be there when in any shell or in any orbit student. N is 1 is 2n square. So what it is 2 into 1 the square. So there are two electrons in the first shell. Similarly, we can find in the second shell. Here, what do you see in the L? In the case of neon, what I have tried to show, neon 1s2, 2s2, 2p6. This is the my first shell. This is the outer shell, which is called the valence shell students. Valence shell. Outermost shell is called the valence shell because here are those electrons which will take part in the chemical bonding students. Electrons can be lost or electrons can be gained. Electrons can be shared. In the chemical bonding topic, what they say that there are two types of bonds which you are familiar. Covalent bond. This is formed by the sharing of electrons students. Bolo, right or wrong? Are you aware of it, sir?
Yeah.
Okay. Then they are saying there is an ionic bond which is formed by the transfer of electron. So there can be sharing of electrons. There can be the transfer of the electrons. For example, if I am writing hydrogen is having one electron, another hydrogen has one electron, so they share, and we show it like this. So there is a sharing. This bond shows there are two electrons, and if I say Na and Cl students, Na is atomic number 11, this is 281, this is 287. So what happens here? It has one electron, it has 7 electrons in the outermost student. This is the Lewis electron dot structures. So this electron is transferred from sodium to chlorine. After this electron is lost, it will become 2,8. So what it becomes? 2,8. This is plus, and Cl will gain one electron. It will become minus, and 2,8, 7 plus 1, 8. So what we say that here there is a transfer of the electrons to form ionic bond. Here there is a sharing of the electron. Why they are doing it? Because the atoms want to become more stable. They want to get octet. By octet, we say that their outermost shell is filled. This was the idea on the basis of which Lewis proposed his electron dot structures. I hope you have read the Lewis electron dot structure, students, in that chapter of chemical bonding. Yes or no?
Yes.
Okay, good. Can I proceed further? There is nothing to hurry. In our
Yeah.
class, we should be comfortable, convenient, easy study, no problem. We are not running anywhere. Our main purpose is to understand the basic concepts of the book, and my main job is to decode the book. Whatever course I take, Cbse, medical, IT, engineering classes, wherever, 11th chemistry, 12th chemistry, science, I decode the books. Whatever chapter is there, I will decode it. Every word written should be understood. That's the main point. If we will understand, then everything is over. We don't feel that we should mug the things. Mugging is not a good thing. A lot of students will say, okay, sir, in chemistry, we have to do a lot of cramming, mugging. Of course, memory part is there in every part of science. But memory after you have understood the concept. This is very important. If we understand, then we memory will also become easy. We will be able to uh, cram them, or whatever students say, we will store them in the memory of our minds, and then in the exam we can write easily, reproduce it. So, because you know already all over the world, and we are taking online classes for the students. We have so many courses with us, first to 12th, all classes going on. Else, also we are preparing students who are going for Canada. Everything we are doing. I am mainly in chemistry and science, and my daughter is also taking so many courses, teaching. And we are taking all classes from first to 12th from students of other countries, Poland, England, Canada, everywhere. I hope there is no difficulty in understanding my English.
No, not at all.
Okay, because that is one of the problems students face. Students, because I teach in English as well as in Hindi, because I have been living in USA. I'm used to English. I prefer to take English, but in India, a lot of people wants Hindi also. So I give my lectures in English as well as in Hindi. So any difficulties there, they are available in YouTube. Okay, now students, what is the story? I am saying that we are Lewis was the first who gave electron dot structure. Lewis electron dot structures for the different molecules. What we are saying, atoms combine to complete octet, and we can show their valence electrons by electron dots. Valence electron means those electrons which are present in the outermost shell. For example, you are saying you have hydrogen, lithium, supposing you have chlorine, you can take any element, no problem, boron, supposing. The atomic number of hydrogen is 1. What is the atomic number of hydrogen is 1. It has only one electron. So we show it like this. If I take lithium, atomic number of lithium is 3. Atomic number is 3. So in the outer shell, it has one electron. Hydrogen, helium, lithium has one electron in the outermost shell. Or if I write the electronic configuration, this is 1s1. This is 1s2, 2s1. This is the outermost shell, valence shell. It has only one electron in the s. So this is our lithium. And if I write carbon, students, carbon atomic number is 6, 1s2, 2s2, 2p2, or 2, 4, K shell, L shell. It has 4 electrons, so you represent carbon by 4 dots. Boron, then hydrogen, helium, lithium, beryllium, boron. Boron is 5 atomic number. Then 1s2, 2s2, 2p1. So boron is represented by 3 electron dots. These are dots are electrons, and Lewis gave the structures of different molecules by electron dots. For example, if two hydrogen atoms are going to combine, you are saying one and another hydrogen has one electron. So there are now two electrons. Both have two electrons, so there is a sharing of the electron, students, HH. So this is an example of sharing of electrons. If I represent oxygen, students, atomic number of oxygen is 8. So it has 6 electrons in the valence shell. This is my valence shell. It has 6 electrons. So how do you represent the electron dot structure of oxygen? 2, 4. It has 6, 2, 4, 6. It needs 2 electrons. So if you have 2 oxygen atoms, what will they do? This is our oxygen. How many? This 6. these are four and these are shared. These are shared by both the oxygen. So you represent oxygen like this. Double bond and how many? Each oxygen has got two pairs of electrons. These are called Lewis electron dot structure. Students, you are aware of this. If you have to write for nitrogen, has got 5 electrons. Nitrogen atomic number 7 to 5. So we are saying there are 3 electrons. So nitrogen, if it combines with another nitrogen, then they will share these three electrons, so that 3 plus 3 6 and 2 8. So each nitrogen gets 8 electrons. Students, 1 2 3, 1 2 3. So here you can see that 8 and this also 8. This is the Lewis electron dot structure. Student, you write it like this: nitrogen. If I have to show H2O, students, then what you say? You are saying hydrogen, each hydrogen, there are two hydrogens, one electron. Oxygen has got how many? 1 2 3 6 electrons in the outermost shell. So we say, okay, oxygen. Then we can say that this will be sharing, out of 6 it needs 2. Each hydrogen needs 1 electron. Each hydrogen needs 1 electron. So we can write it like this: 4 H H. So one bond represents 2 electrons. Student, 2 electrons each gets their outermost shell completely filled. This was the concept which was given by Lewis. Is given in the chapter of chemical bonding. I hope you know about it, students. Akshat, you know
Yeah.
about it.
What is it?
Are you aware of these Lewis electron dot structures in the chemical bonding?
Yeah. Yeah.
Okay. All right. Any doubt here?
None at all.
Okay. Now you can see, students, the important point is that the Lewis electron dot structures, they can be drawn as we have shown you, but they provide no information, but they provide students no information about the shapes or geometry of the molecules. They give no idea about the shapes and geometry of the molecules. You know that these molecules which we are talking, they have shapes, they have geometries. And we know by experiments like X-ray and other, their shapes have been determined. So this gives no idea what is the shape of a molecule. And you are saying carbon dioxide is linear. You are saying CH4 molecule is tetrahedral in shape. And certain molecules you are saying, for example, we have know from experiment that this compound is linear in shape. And what they say, BCl3 experimentally found that this has a triangular planar shape. Triangular planar, triangular planar shape means what? Linear means what? It looks like this. It's a linear. The bond angle will be how much if it is linear? 180 degree. Triangular planar means it looks something like this. Students, Cl, the bond angle 120 degree. Now, how do we explain the shapes of the molecule, student? That was the question. So one of the theory which has been proposed is VSEPRT, students. What it means? Valence, S means shell, E means electron, and P means, students, pair, R means repulsion. I hope It is clear to us what we are talking about, students. Valence shell electron pair repulsion theory. That means in the valence shell, what is the valence shell, student? What is the valence shell? I have been telling there is a valence shell. What we said, the outermost shell. In an atom, there are shells and electrons are orbiting around the nucleus, you are saying, and the outermost shell is where they will participate in the chemical bonding, students, because the inner electrons are strongly, tightly held by the nucleus. So those electrons which are present in the outermost shell, we are saying valence shell. That is where the reaction will take place. That is where the electron will share or be transferred to other elements, or that is where electrons can come. So that is why we are talking of valence shell electron pair. These electrons are negatively charged particles. They will repel if they are closer to each other. So what will happen then? They will try to move further away from each other, because students, more repulsion means less stability and more energy. As I said, the main thing is that molecules become stable by because they want to have lower energy. Lower energy means there should be less repulsion between the electrons which are present. The minimum repulsion should be there, and the shape will be like that if we are able to calculate, students, the total number of electron pairs in the valence shell of the atom which is forming bonds with other atoms. Then we can propose the shapes of the molecules using this idea. I hope you understand what I am saying. What we are saying, the electrons will repel. ठीक है? Yes or no?
Yeah.
Because they are having same charge, negative.
Yeah.
And if something repels and molecule is formed, it will try to go farther away from each other. They will try to occupy position, students, which are farther away. Maximum distance they will go away. Two persons don't like each other, they want to be away from each other. Here repulsion is taking place. And here we are talking of valence shell electron pairs. Electron pair, because one pair, student, one pair means there are two electrons which make a bond. A bond is formed by two electrons. So we call it a bond pair. Bond pair means when bond pair, I am saying, bond pair will be there, student. Bond pair, if there are two elements X and Y, student, if they form a bond, this is a bond pair. One bond pair is how many electrons? Two. When I write this line, it means there are two electrons. How many electrons? Two. So this is a bond pair. But if there is a lone pair also, lone pair. Lone pair means that this pair of electrons is not participating in bonding. There, because depends on the number of electrons in the valence shell. Lone pairs means they are not participating in bonding. They are not forming bond. Those electrons which are not forming bonds, what we call them? Lone pairs. Those electrons which will form a bond, we will call them bond pair. So there will be two types of electrons. What we are saying further, students? How do we predict the and form the shapes by using, how do we give the shapes, students, using valence shell electron pair repulsion theory? We have to calculate, student, first. We have to calculate the number of electrons in the valence shell of central atom. Central atom. And after that, we can decide the shapes of the molecule, student. There will be two types of bonds. There will be bond pairs and there will be lone pairs of electrons. Bond pairs are those which are forming the bond. Lone pairs are those which are not forming the bond. In any molecule, there are two possibilities. So there will be, basically we have to find electron pairs first. How many electron pairs are there in the valence shell? One electron pair will have two electron students, and we said these electrons repel each other. The repulsive forces, the repulsive interactions have been calculated already. Repulsive interaction between where? Between electron pairs. Between electron pairs will take place, student, and we should know that lone pair repulsion will be greater than, will be, this I represent now, this lone pair repulsion will be greater than, students, lone pair bond pair repulsion, and this will be greater than, students, bond pair repulsion. These are, I'm saying lone pair repulsion will be more than lone pair bond pair repulsion, which will be more than bond pair repulsions. So on this basis, we are saying the lone pairs and bond pairs will try to go farther away from each other, which will give a particular shape or geometry to the molecule. Because there are repulsions, how will you minimize the repulsion? The idea is valence shell electron pair repulsion theory. You are saying the pairs of electrons are repelling. Either they are bond pairs or lone pairs. And when they repel, what will happen? These electron pairs, if they are repelling, they will try to go farther away from each other. Farther away from each other to form the shape of the molecules. We are going to take examples in order to prove these points. How do we say and how will we calculate? I hope you have noted these points. Then I will proceed further. What I am talking, VSEPRT theory. So valence shell electron pair repulsion theory, we are solving, students, and we are going to take some examples of this in order to find the shapes of different molecules. Examples. Certain molecules, for example, if we have molecules like AB2 molecules, what is we mean by AB2? Like BeCl2. Supposing this is the molecule, and I say predict the shape, using VSEPR theory. Now beryllium, we have to know what is the atomic number of beryllium, hydrogen, helium, lithium. It is 4. It is 4, 1s2, 2s2. It has only 2 electrons in the valence shell. So how many electrons are there in the beryllium valence shell? 2 electrons. Valence electrons, how many? 2. In the case of beryllium, valence electrons 2. Now when it combines with Cl, students, Cl is 2, 8, 7. Chlorine is 2, 8. Chlorine will share how many electrons with it? Because it needs only 1 electron to complete octet. One chlorine will share 1 electron. There are 2 chlorines. How many chlorines are there? 2. So 1 chlorine will share 1 electron, total 4 electrons. So you have how many electrons, students, in the central atom? What is the central atom here? Be. This is my central atom, Be. So total electrons, how many? 4 electron pairs. There are two electron pairs, two pairs. And you know how many bonds it is forming? Beryllium is forming two bonds, one with two Cl. There are two Cls. This is AB2 type. AB2 type means BeCl2 is example of AB2 type. There are two bond pairs in this case because Be is forming two bond pairs. And when there are two bond pairs, students, then what will be the shape of this molecule? In this case, I am saying bond pairs are 2, lone pair 0. Because 4 electrons only, two bond pairs will be formed. Then what will be the shape of this molecule? AB2 type molecule, they will have linear shape, student. What we linear shape. And the molecule will look like this. Because these want to be, they are repelling. After repelling, what will happen? They will move to farther distance. The maximum separation which can there be in a linear is 180 degree. 180 degree bond angle. They cannot be farther apart than 180 degree. Total angle is 360. You know that. Is it? Do you understand what I said?
Yeah.
Okay. So we can start writing the shapes of the molecules. Supposing you have students BF3 molecule and they say predict the shape of BF3 using valence shell electron pair repulsion theory, student. What is the atomic number of boron, student? It is 5, 1s2, 2s2, 2p1. This is my valence shell. Outermost shell is a valence shell, student. How many electrons are there in the valence shell? Electrons. This is my central atom. Boron is the central atom. Electrons in valence shell. Boron has got 3 electrons. What is the fluorine? Fluorine is 9 atomic number. 2, 7. This is 2, 3. 2, 3. So there are 3 electrons in the outermost shell. This has got 7 electrons. 7 electrons in the valence. It needs only 1 electron. It needs 1 electron. How many fluorines are there? 3. So it 3 fluorines will share how many electrons with boron with central atom of the valence shell. Each fluorine will share 1 electron. Each fluorine will share 1. So that 7 plus 1 becomes 8. 3 fluorines will share how many electrons? 3. Total electrons in the valence shell. Total electrons in the valence shell of boron central atom. How much will it will be? 6. And electron pairs will be how many, students? Tell me how many electron pairs? 3.
Three.
And how many bonds boron is forming? 3.
Three.
So bond pair 3. Each bond pair needs 2 electrons. Each bond pair needs 2 electrons. So 3 bond pairs have been used. Then lone pair is 0 here. So if there are, this is an example of molecule like AB3. This molecule is like AB3, students. Now what is the best separation? Because bond pairs are repelling and where maximum separation which they can go in this case. And you will find the mathematical figure, geometry which will come will be the maximum separation can be, student, 120 degree. This is also 120 degree. This is also 120 degree. What is the shape? What it looks like? Triangular?
Yeah.
Planar. Okay, so good. You know it so well. I know your intelligence is very high. That I can say. I find students from your country are very highly intelligent. So I always like you. People, you can do all the course with me from first chapter to all. No problem. Your book is very good. I've seen the book. Earlier, I am teaching another book from Oxford, written by Owen. That also OWEN. very interesting because the student has sent me the PDF of the book. A very good book from England course. That course is given in England. So you will enjoy a lot. I mean, all the course step wise we can do, no problem. We are taking students from all countries. Poland also we have students. Any course can be given. Now just see that what we are doing, students. This is a triangular planar. And supposing students, we want to predict the shape of CH4 using VSEPR theory. Carbon atomic number 6, you are saying 2, 4. What are the valence electrons? See how easily we calculate. Valence electrons in the carbon 4. Each hydrogen, how much has only one electron? Hydrogen only one electron. So there are 4 of that. 4 hydrogen will give how many electrons? 4 valence electrons, student. How many valence electrons? 8 valence electrons. Valence electrons 8. How many pairs? Electron pairs will be how many? Electron pairs 4. How many bonds it is forming? Carbon. Carbon is my central atom.
4.
4 bonds. So each bond pair needs how many? 1 pair, 4 pairs. So are there any lone pair left? 0. And in such cases, the shape is tetrahedral. Is that three-dimensional figure, students? And the bond angle, each bond angle is 109.5 degree. This is the best way that repulsions can be minimized. All the valence shell electron pair repulsion theory is saying repulsion should be minimum. Minimum repulsion means lower energy. Lower energy means more stable. Everything wants to be stable. So we have to give stability to atom. We have to give stability to the compounds, to the molecules which are being formed. If something is stable, then it will not react. You are saying helium is very stable because it has 8 outermost shell filled, so it is not reacting. Neon is stable. Neon is noble gas. It is not reacting. And those who are reacting wants to have their outermost shell completely filled. This is called octet. But we're talking of octet of electrons. Octet is a stable state, student. Octet is a stable state. See how we build the story, student. And slowly we can start writing the geometry or shapes of the molecules using valence shell electron pair repulsion theory. Valence shell electron pair repulsion theory. Let us go further, student. You are very intelligent students. You will understand very fast. Supposing we are saying NH3 molecule. Okay? We have to predict the shape of this using valence shell electron pair repulsion theory, VSEPR. Nitrogen atomic number is 5. We are saying 2, 3. Hydrogen, no problem. Already you know 1 atomic number. It has only 1 electron. So valence electrons will be how many, students? Valence electron, central atom is nitrogen. Nitrogen valence electron, how many? 3 are coming from here and there are 3 hydrogens. Nitrogen 3, 3 hydrogen will give 3. How many? 6. So what we are having, nitrogen is, I have done a mistake here, student. Let me do it something. What happened? Nitrogen atomic number is 7. Something is there. Okay? Correct it. It is 7. Then what is the story, students? Okay. Nitrogen is 7. 5. So there are 5 electrons. 3 hydrogen, 3 electron. Total 8 electrons. So 8 electron means how many electron pairs? 4. Electron pairs, how many students? 4. But here, how many bonds are being formed, students? How many bonds nitrogen is forming?
3.
3. So, 3 bond pairs means how many? 3 pairs are used up. So, what will be left? Lone pair, 1. So, here you are seeing that in the case of ammonia, student, in the case of ammonia, nitrogen is bonded, nitrogen is forming 3 bond pairs and 1 lone pair. ठीक है? Now there are total of 3 plus 1 is how much? 4. Lone pair plus bond pair. Bond pair plus lone pair is 4. If I say now it is tetrahedral, but one nitrogen, if I put it like this, student, tetrahedral, but what happens? There are only 3 bonds and 1 lone pair of electron. 1 lone pair of electron. This is my lone pair. These are bond pairs. ठीक है? If the what will happen to the geometry now? What the shape will look like? What the shape is not decided by the lone pair, student. The shape is shown by the bond pairs. The shape will be what now? This is not tetrahedral now because one is lone pair. So this will appear. What shape we call it, student? This lone pair is not going to be there when we discuss the shape. This is trigonal pyramidal. What we call it? This shape is called trigonal pyramidal, students. So ammonia shape is trigonal pyramidal, and this bond angle will also be reduced because there will be a lone pair bond pair repulsion. Lone pair bond pair repulsion. The bond angle will also be reduced. Therefore, the shape of ammonia is, student, trigonal bipyramidal. Okay? Convinced?
Yeah.
We are trying to predict the shapes of the molecules using VSEPRT. Let me go further, student. We are saying predict the shape of H2O using VSEPRT. What are the steps? Now you are so much familiar. You are saying oxygen.
Mm-hmm.
Oxygen, what is the atomic number of oxygen? 8. So 2, 6. How many valence electrons in oxygen?
6.
6. Very good. Each hydrogen, how many? Hydrogen has only 1.
1.
There are 2 hydrogens. This is coming from oxygen. 2 electrons are coming from this. Total, how many? 8 electrons. And pairs, how many pairs? 4.
2 pair.
8 by 2, 4 pairs of electrons. But how many bonds are being formed? Oxygen is combining with the 2 hydrogens, 2 hydrogens.
Oh.
So 2 bond pair, then there will be 2 lone pairs in the case of H2O. ठीक है? Total
Yeah.
2 plus 2, 4. Whenever we have 4, lone pair plus bond pair is 4 means what? That tetrahedral, but there will be 2 lone pairs and 2 bond pairs. If I draw like this, when I say this is supposing tetrahedral, but there are 2 lone pairs. There are 2 lone pairs and bond pairs. What will happen, students? What will be the geometry? What will be the shape of H2O then? How it will look like? There are 2 lone pairs. There will be a lone pair repulsion also, you know that, which is greater than bond pair. So they will reduce this bond angle. This is a bent molecule, student, bent molecule. What is the shape of H2O? It will be a bent molecule, H2O. This is not going to show in the shape. This is the shape of the H2O bent molecule. ठीक है?
Yeah.
Okay, very good, students. Some shapes are now becoming important to us, students. See the interesting thing. Some more interesting things we are going to see, students. We are going to find some more interesting things. For example, a question has been given in the paper. Predict the shape of ClF3 using valence shell electron pair repulsion theory, students. So how will we predict the shape of this? How will we predict the shape of this? Cl is 17287. So how many valence electrons, students, in ClF3? 7.
7.
Valence electron in Cl, 7. And F you already know, 27, 9 atomic number. Each fluorine is sharing only one electron. Each fluorine is sharing only one electron. 7 plus 1 becomes 8. So 3 fluorine will give how many? 3 electrons. Total valence electrons 10. Total valence electrons 10. There are 5 pairs of electrons. 5 pairs of electrons, students. How many bond pairs are there?
Um,
3.
3.
ClF3. And then how many lone pairs will be there? Out of that, 2. So total lone pair plus bond pair 5. When you have 5, then this should be trigonal. What they call, when it is 5, student, 5 will mean what? Trigonal bipyramidal. But there are 2 lone pairs. 2 lone pairs. Something like what we are trying to show you, student. Here A, B, AB3, E2. E2 means this molecule is AB3. E2 means these are electron pairs, 2 electron pairs, 2 lone pairs. E is lone pair. E is lone pair. So there are 2 lone pairs and there are 3 bonds. These are bond pairs. This is my bond pair. 3 bond pair, 3 lone pair, E electron pairs, 2 electron pairs and 3 bond pairs. The shapes should be trigonal bipyramidal. What do you mean by trigonal bipyramidal, student? When I say this molecule, it is something like this. If A is the central, this is a bipyramidal, something like this. Bipyramidal. This is a bipyramidal, but there are 2 lone pairs of electron. Now the question is, this is a triangle. This is a triangle. The bond angle 120 degree. This is a axial 90 degree above and below the plane of this. Now where will these lone pair of electrons go? To make the repulsion minimum. Repulsion to minimum. The electron pair will go, students. Electron pair will go here. Equatorial position. Any one of the 2. These are the lone pairs of electrons. If these are the lone pairs of electrons, then where is the other one? So you are having AB3. This is my AB3 molecule which I have shown, students. These are the lone pairs. It looks like molecule will look like AB. Molecules look like this. There are 2 lone pairs of electrons. These are the lone pairs of electrons. Lone pairs. So in the shape they will not be showing them. What we show then, in what will it look like? What will be the shape of? What is the shape of this? How it looks like, student? It will look like T shape. We call this as a T shape. So in this case, ClF3, what it will look like, student? ClF3, it will look like Cl, there F, and you have electron pairs. So what is the shape? T shape. We call this as T shape. So the ClF3 molecule is T-shaped, students. So we can predict the shapes of different molecules by using valence shell electron pair repulsion theory, valence shell electron pair repulsion theory. Do you get it?
Yeah.
Okay, I'll take another one more example. Predict the shape of SF4 using VSEPR theory, students. Sulfur is in which group? Oxygen, sulfur, selenium. This is group 16 of chemistry. It has sulfur is 16286. Sulfur has got how many valence electrons?
6.
6. Fluorine will share how many? One electron. Each fluorine shares only one electron because fluorine is 27. So it needs only one electron. This is a central atom. This is a central atom. In the valence electron, there are 4 fluorines which are forming bonds, student. So in the valence electron of fluorine will be how many? 4. Total you have 10 electron. There are how many? Then 5 pairs of electrons. 5 pairs of electron. But out of the 5p, how many bond pairs are there? 4 bonds they are forming. Bond pair 4. Lone pair, how many lone pair will be left then? 1.
1.
Now again, it should be tetrahedral, but there will be one lone pair of electron. One lone pair of electron. This trigonal bipyramidal is this shape. This is my trigonal bipyramidal shape. But in this case, what is the story that you have, students? What you have? This sulfur, you have 4f, 4 bond pairs, and there is a lone pair. This is my lone pair. So how it will look like, what shape we call this, student, how it will look like. This lone pair will not show in the shape. This shape is what we call as seesaw. Seesaw. This is called seesaw shape. Something this, what the carpenter uses, that seesaw,
Okay.
seesaw shape. SF4 is seesaw, students. So here we have discussed with you valence shell electron pair repulsion theory, students, and we have told you how to draw the shapes of this. I hope you enjoyed the session. I will meet you in my next class.
All
And
right.
what chapter you want to study, you will tell me. My phone number is with you, mobile number is with you, WhatsApp number is there, and my mail ID is also scholarsikri55@gmail.com, students. 9971058053 is my mobile. You connecting with India, what you are adding 91 or something. Then YouTube channel, already you know about it. So you can communicate with me. I can fix your classes accordingly. And whatever course you have, you will tell me which chapters you want to start, chapter 1, chapter 2, or what chapters. We will be able to do whatever things you want. And also you will keep on getting recorded videos in the YouTube, which you can subscribe. Whatever we teach you, this will also come in the YouTube, which you can see yourself. If you have doubts, you can again connect with me. So
Okay.
how do you feel about this?
I I understand it. I understand it now. Yeah.
Okay, okay. Any other students who want to take classes with us, they can join with us, no problem. Our we will be able to teach them any type of chemistry for any college level, any graduate level, or any class. And science classes also we are taking, and we are also taking classes for first to eighth students. Any students from your country can join us. Okay, then bye bye. We will meet you in our next class. I liked the session with you. and I
All right.
enjoyed you. You are quite a good student, and I wish I would be able to meet you also someday. I'm living in Delhi. Okay,
Okay.
once you come
All right.
to India, Delhi, you are welcome to visit me.
All right.
Okay, bye bye.
Okay. All right. Have a good day.
Okay, have a good day.